Now, let's consider the following rational expression. Suppose we consider a minus b over b minus a. Okay. This looks an awfully lot alike. If you notice, we have a plus a in the numerator and a minus a in the denominator. We have a minus b in the numerator and a plus b in the denominator. That means that whenever all the signs of each of the terms is just the opposite of what you have in the denominator, that means that these expressions are related by a minus 1 factor. And so let's do the minus 1 factoring. Let's take out a negative 1. Let's factor out a negative 1 from the numerator, and let's look and see what happens. If I factor the negative 1 from the numerator, I'm going to end up with a negative a here and a positive b here. Now, let's check that to make sure that we get what we started with. Minus 1 times b is a minus b. Minus 1 times minus a is a plus a. But look now what happened. We've got a minus 1 factor times b minus a over b minus a. Those are the same factors, and we can use the cancellation property and say b minus a will cancel the b minus a, and we end up with negative 1. So try to recognize when you have that situation and you're trying to simplify, because that will help you save a lot of time. Notice that in factoring the negative 1 out of this expression, the quantity, the other factor that remains, is just the expression written just the other way around. If I have a minus b and I factor minus 1, then in the parentheses that expression will be b minus a. So let's consider then something that has this negative 1 factor situation. Let's consider an example. 5k minus 10 divided by 20 minus 10k. Okay, this is a rational expression, and remember, you need to always be thinking that in case you need it, you should be thinking that the domain is going to eliminate certain values of k. But from now on, let's assume that we're going to be working with these expressions, and we're going to be assuming that we're throwing out those values that make the denominator 0. All right, so now anytime that you want to simplify an expression, factor first. So let's factor out the common factor in the numerator. And so we're going to factor a 5 from the numerator, and we're going to be left with k minus 2. Because 5 times k is 5k, 5 times minus 2 is a minus 10. From the denominator, we have a common factor of 10, so let's factor that out. 10 times 2 is equal to 20. And 10 times a minus k is equal to a minus 10k. Okay, we were able to factor the common factors, and now we've got a k minus 2 and a 2 minus k. Well, these two expressions right here differ by a negative 1 factor, so we can go ahead and factor that out. And you can do that either in the numerator or in the denominator. It really doesn't make any difference. So if we factor, let's do it in the denominator this time. If we factor a negative 1 from the factor in the denominator, then what I have left is a k minus 2. Negative 1 times k is negative k. Negative 1 times minus 2 is a positive 2. And the numerator remains the same. We have 5 times the expression k minus 2. But now we've got a common factor, the k minus 2's. We can cancel that common factor. We also have the 5 and the 10, which have a common factor of 5. So we can say 5 goes into 5 1 times, 5 goes into 10 2 times. And what we're left with here is a 1 for the numerator and 2 times negative 1 for the denominator, which gives us a negative 2. So we have a negative 1/2. Remember that with rational numbers, if you have a negative in the denominator, you can either write it in the numerator or write it out in front, minus 1, minus the quantity 1/2. Okay? And so that's what we can do over here. So we're canceling common factors here. Anytime that the entire numerator or the denominator, if that's the case, anytime that everything is canceled out, make sure and realize that you do have something left there, and in this case that's a 1. Okay? Sometimes it's tempting to say I've canceled everything out and I have a 0 left there, but that's not the situation. Okay? All right. Now let's look at an expression which is a little more complicated. Suppose we have an expression which is 2 times h to the 4th plus 4h cubed minus 16h squared, and that expression is divided by 2h minus h squared. We have a rational expression in h, and the job in this case is to simplify. So in order to simplify, what we're going to do is we are going to first factor out everything that we can, and once we factor out everything that we can, we're going to be canceling out the common factors and then writing the expression in lowest terms. Notice for the numerator right here, what we have in the numerator is we've got h squared that's common to all three terms, and we also have a 2 that's common to all three terms. So let's start out by factoring 2h squared from the numerator. Okay. When we factor that out, we're going to be left with h squared for the first term, we're going to be left with 2h for the second term, and we're going to be left with a negative 8 for the third term. Check your work, or check my work in this case. 2h squared times h squared is 2h to the 4th. 2h squared times 2h is 4h cubed, and 2h squared times a negative 8 is a negative 16h squared. So that checks out. Now, in the denominator, we have a common factor of h, and so we're going to be left with 2 minus h. Okay. Now, in the numerator, we've got a factor of 2h squared and then a trinomial. We may be able to factor that trinomial some more. If we can factor it, we're going to have two factors. Since I have a negative sign here, the signs inside the factors will be different. And we need factors of 8, which give us a sum of 2 in this case, and so 4 and 2 will work because the difference is going to be 2. And we want, in this case, the 4 to be the plus 4 and the 2 to be a negative 2. And then h plus 4 and h minus 2 completes that factor form. But let's check it out. The middle term is going to be 4h minus a 2h, which gives us a plus 2h. Plus 4 times minus 2 gives us the negative 8. So we factor that correctly. And now for the denominator, we're going to have h times the factor 2 minus h. Well, once again, we've got some common factors here. Notice that in the denominator, we have an h. In the numerator, we have an h squared. So we can factor one of the h's from the numerator and say that one h will cancel the one h in the denominator. And then we've got h minus 2 and 2 minus h. Once again, we've got that negative 1 factor. So let's factor a negative 1 out from the denominator, from the factor in the denominator, and we can write that as negative 1 times h minus 2. And from now on, I'm going to, once I factor something in the numerator and the denominator, I'll put a line through it to show that I've expressed it in a different way. So what I have then in the denominator is negative 1 times h minus 2. Now, we've got an h minus 2 in the numerator and an h minus 2 in the denominator. Those two factors are common factors. They can cancel out. And so what we have finally is we have an h plus 4 in the numerator. We do have a 2h in front of that, another 2h factor. And then in the denominator, we're left with a negative 1. Well, we can write that a little more simply as just simply minus 2h times h plus 4. So even though the expressions may be fairly complicated, if you follow the rules of factoring, because the first thing we want to do is factor completely, follow the rules of factoring. First, factor out the greatest common factor if you can find it, and in this case that was the 2h squared. That left us with a trinomial, which is then a lot easier to factor as the product of two factors, and then go on from there, canceling common factors. Okay? So let's review what we've done in this section. What we did is we had rational expressions, and we wanted to express those expressions in lowest terms. So as we did with this particular problem, we factored completely first. Then we canceled common factors from the numerator and the denominator. And notice that it's very important that you have factors to cancel. You cannot cancel inside quantities inside a factor the expressions inside which may not be factors. So you must have factors to cancel. And then we have this -1 factor technique, which often simplifies the problem because then we can get rid of more factors. So if we have two expressions, they have opposite signs in all the terms, then the expressions differ by a -1, which can be factored out, as we did over here. We factored the -1 from the denominator, and that allowed us to cancel the h minus 2. So you might review the three parts over here to be able then to simplify rational expressions.